Hey everyone, welcome to our event. This event is brought to you by Data Rocks Club, which is a community of people who love data. We have weekly events, and today is one of such events. And if you want to find out more about the events we have, there is a link in the description. This screenshot is so outdated. YouTube changed its interface like 10 times since then. I think I should update. But anyways, you get the idea. So just go below the video. There is like in the description, piece, and then you'll find the thing with events there. And then the subscribe button looks differently for you now because YouTube changed the interface, but I'm sure you will find it, and please do. And when you find it, click on this, because this way you will get subscribed to all our events, future events like the one we have today. And we also have an amazing Slack community where you can hang out with other data enthusiasts. So the link is also in the description. During today's presentation, you can ask any question you want. There is a link in the live chat. Click on that link and ask your question. And I think, Loïc, we will cover these questions after the presentation, right? So first you do the presentation and then do the Q&A part, right? Or it's okay to interrupt you sometimes if a question we see is on topic.
I think the best is I go through the presentation because some answers are getting done, given later.
Yeah, we'll do it like that. So first the talk and then the Q&A part. And with that, I give the floor to you. Please start.
It's the time for me to share my screen and go through the
Yes, exactly. You got it.
So can you see the screen? It's all good?
Yes.
Perfect. So this is the menu for today. I'm going to start with presenting Medallion, the company where I work, and myself. That was for the pen. Then we go to the mains. So the mains is going to be why we built a data lakehouse. It's spoiler, it was in the title of this webinar. And then I'm going to walk you through a few steps that I think are the most important one when you are building a data lakehouse, which are on the slide. We will cover them one by one, and dessert we will wrap up and Q&A. So let's start with the starters. Myself first. So I started my career 10 years ago, 2013, as data manager. Then I really liked the data engineering side of things, so I went to data engineering, lead of a team where I was working in the. Went back to France in 2019. Started my career as a big data consultant, so doing data warehouse, business intelligence. And then I had two missions. One was the data product owner at Schneider Electric, and with the same client, Schneider Electric. The second mission was to work as a data factory tech lead. And finally, in 2022, I joined forces with Medallion as a lead data and data architect. So this was just to show that I've been basically ramping up the different stages of data engineering to data architect. A bit on the personal note, it's been 20 years I played the guitar. I got 15 bags that I saved from trash. That's one of my spare time activities, just repairing old bikes. I like to do this. And I speak 3 languages, which is English, French, and Spanish. I try my best with English today. So let's talk about Medallion 150. So the motto of the company, of the group, is to make the sun our primary source of energy. And for this, we have basically 2 companies in the group. The first one is called Alaska Energies. It's a distributor specializing in positive energy building. System manufacturer. So what do? We build hardware to help you optimize your self-consumption. And we also have this ability to do design and simulations for your photovoltaic projects. And we have optimization algorithms called the Green Play that can basically put your house in autopilot. So you make the most out of your solar production by moving the appliances during the day. Somehow. And we became recently a green energy provider with an offer called My Smart Battery, where basically everything that you produce and do not consume during the day, we put it into a virtual battery that then you can use during the night or during the winter. So this is the job of MyLight. As a group, some figures, we have 90 million turnover last year, 2022, with 85% growth forecast in 2023, 25K installations, so houses with those devices, and registered with our R&D department. This is a proof that we invest in R&D, and we are in 4 countries, which are France, Spain, Romania, and Switzerland. Data department within MyLight, to present it briefly. So the role of the data department is to address all the group needs. And for MyLight Systems, it's more of a tech company. We do data science for product and energy trading. And for Alaska Energies, it's more of a classic business intelligence for all the services. So it's like reporting for marketing, sales, supply chain, finance, etc. And the challenges, as you noticed by the numbers earlier, is that as both companies are scaling up, the volume of data and the associated analytics are just increasing. Like there is more data and more consumers, and we need it to basically scale the data. So by the title of the presentation, the first thing is we had the typical.
Look, I need to interrupt you. It looks like there are some problems with the internet connection, and it might be on your side. Is there any alternative connection you can use?
There is. Give me a sec, please.
I asked in the live chat, and it appears it's not just me.
Give me a sec, please.
Yes, hope we will see him back when he connects to a different network.
Okay.
Are you back?
Now I should be back.
You are back, and I can hear you, and I hope there will be no interruptions.
Yeah, I hope so as well.
Yeah, maybe if you can go one slide back and start.
Yes. So the one slide back was.
Yeah, this.
Yeah, good. Perfect. So why data lakehouse? So let's go for it. So we had at MyLight, we had the typical unscalable reporting, which looks like when you arrive in a company that is basically going from a startup to a scale up, that you have loads of reports. Some are dead, some are not. You have multiple data sources, and all of those reports are basically connected straight to the production databases. This is the typical scenario that you need to solve. And as you were connected to multiple data sources, what happens is in the reports, this is where the complexity is hidden. So you need to do a lot of investigation to figure out all the data you need to make those reports work. And most of those reports were quite big. So you end up with duplicated intensive queries on those system sources. And you basically need to offload the databases so that you can do your analytics. So we did not have a data warehouse, which is mostly used to store structured data. And it's mostly for SQL and for BI. Usually you will basically offload the ERP and your CRM to the data lakehouse and do your analytics. You still have coupled compute and storage when you build a data warehouse and not a data lakehouse. And at MyLight, we had a very active data science team. So we had an open data lake already with like unstructured data, mainly coming from IoT and API data. Good thing it was cheap and scalable storage. Decoupled from the computing, we were using Databricks and Spark to do the machine learning and other data computations. And data was stored in Parquet format and a few data tables for the bringing Parquet files together and building data tables. So we already had this legacy, which was a good route for data lakehouse, sorry. So we decided to build a data lakehouse where you basically can store both structured and unstructured data. That's the key point of the data lakehouse. And then as you can store both types of data, you can use it for BI, data science, and at MyLight for product analytics. We have a huge volume of IoT data. We can use Python, SQL, and PySpark in the team. So it was a very good background to build a Lakehouse using Databricks. And as I said, experience with Databricks was already deployed, and we had to rebuild the business intelligence reporting anyway to make it scalable. So this is the technical reason why we went for a data lakehouse. So now we're going to go through the different steps of building such an infrastructure and what you can expect along the different the time you are going to take to do this build or migration, depending on your case. So the first thing and the most important one is to map the current data processes and organization. So what do I mean by that? You need to list all data sources, the model, transformation, and lineage. And this will help you to identify if you have... Is the connection still okay? Because I got some messages. Yeah, cool. So
like it has been fine since you switched to a different.
Perfect. So yeah, you need to list all data sources. This will help you to figure out if you still have, if all data that you use in your pipeline is still relevant to this day. Identify the data quality and processing bottlenecks. This is very important in case you need to do any reworks in your pipeline, and depending on the size of those bottleneck and data quality issues, it will help you prioritize the build or migration. And you need to understand the data consumer pain points. One big time classic to illustrate this is when you have a report, you have multiple sources of truth usually. And for example, the finance department can look at the turnover, looking at the ledger entries, while the sales department is calculating the turnover based on signed invoices, for example. And this is something you need to arbitrate, and you need to talk to the people to understand what is the source of truth. Related to the first one, observe and understand the current data reports, find the source of truth. And then once you have all of those information, it's ready to explore and map all the ETL process you have in place. Like discuss with the team, open the code base, check the source, the sync, the transformation script, whatever it can be. Just map everything. And you will end up with, in my case, for a portion of the job, with something like this, where you have all the OLTP transaction maybe on one side and all the OLAP transactions. So OLTP is online transaction processing and OLAP is analytical processing. The difference is basically one is interconnection between the different databases and tools, and the other one is offloading to analytics. So try to do your best to map everything, because this is a very important piece of document that you will need to figure out a piece of this architecture that you can start working with, for example, and see all the dependencies in general. So yeah, a little meme for spaghettis. Technical is one thing, but then you need to have a look at the team, how it's organized as well. So list the people and tools that they are using, and I'm just gonna narrow it down to the data department, so we can so it talks to the audience. So for example, when I arrived, there was a data analyst. He was working in the IT department and not in the data department with the other data scientists. So this can cause a bit of misunderstanding sometimes. He used a low-code, no-code solution to handle all the ETL from one data source to another. And this solution is like an off-the-shelf, and it wasn't doing everything. So he had to do some extra stuff in Python. And he managed to connect like 100 Power BIs directly to the on-prem and production databases / APIs. So very prolific data analyst. And the data science team on the other side was working on the Azure cloud, mainly with Azure Function developed in Python to handle the optimization algorithm. They were using Databricks for when the volume was more important. to do machine learning as well. And data batches, they were in multiple languages, so Python, PySpark, SQL, and there was not a lot of consistency in the processing. So sometimes you had a for loop with a Python script, and it was just not scalable because the more clients you have, the longer your loop will take. So a bit of rework was required there. And we had different storage solutions. So we have a SQL database, XML file, CSV, Parquet, and Delta. So luckily, we had a little bit of Delta. So yeah, map this and understand how people are using how they are working together and what are the weak points in the organization, and try to take note of everything. Because when you build a data lake, it's not only about the technique and the data, it's also about the people and the organization. So then you need to define the target architecture for your data lakehouse. So again, technical and organizational. So technical, you need to list the technologies, storage types, and tools/languages you will be using. And my advice here is to simplify it as much as you can. As we say, less is more. If you have less technologies, you will need less expertise when recruiting. That's always good to not look for a super polyvalent profile. And then when you have less languages, it's better for maintainability and collaboration in the team, because when you are on holidays, you can cover somebody else, whatever. And you can challenge the code of another person in the team, for example. Organizational, it's all about people, practice, habits, and relationships. There are many schools here when it comes to organization. My advice is to have all the data people and profiles working together somehow. So I'm not a big fan of the decentralized models, because usually you have them into different business units or teams, and they do not communicate together, and they end up reinventing the wheels on their sides. I'm more a fan of the federated/centralized model, because you can get all the data people together and build career path for those people. So let's talk about the technical side. So on our side, it was to remove this magic software ETL, low-code, no-code solution that was in place, because nobody knew how to maintain it except a subcontractor. And that's a sort of technical debt that you can't afford when you are scaling up. We went to, we rewrote SQL ETL into Python for small data and PySpark for bigger batches, just to have two languages handling the ETL. And we had a lot of code written and running on Azure Functions. Azure Functions are really scalable, but as everything else was using Databricks, we decided to rework it in MapReduce logic in Databricks. So all the code base is in the same place, and we are not maintaining the infrastructure for Azure Function plus the infrastructure for the Delta Lakehouse in Databricks. Again, it's about the minimization, which is my sort of motto when I build architectures. Then we decided to have all data in the same place. This is what makes the more sense. Store all data in the standardized fashion. So usually when you come from a BI/data warehouse background, you have your raw, processed, and serviceable data. So the Medallion architecture from Databricks is basically the same thing, where bronze is your raw data, silver, you are going to do some filtering, data quality checks, renaming of columns, and you will have it already somewhat consumable. And then you have the gold level, where you bind different silver tables, and you can do analytics use case by use case. So this is to make the usages scalable in terms of people know what to expect in silver and gold tables, in gold layers, sorry. And it's somewhat becoming a new modern industry standard when it comes to data in terms of data platforms. One thing that was a limitation in the Databricks platform was the way it was handling the workflow. Moreover, if you are building a pipeline which is based on idempotence, like you run an activity and, for example, you didn't catch the data, the next pipeline should not break, and you should not stop all of your pipelines when one activity fails. You should go all the way and have your pipeline handling the error previously done and alerting, of course. But the way we wanted to design the architecture with idempotence was not covered by the classic data workflows from Databricks. So we added the Azure Data Factory as a new layer, which is good because it has all the CI/CD, which is like very easy to implement, low code, no code orchestration, and there is monitoring built in. So when your pipelines are failing or whatever, you can find it and you have native monitoring. On the organizational side, it's an iterative process. So what I will do here is show 3 different ways we work with in the company with the model and the value added by the data team. So we have when services, they can invest in their own data profiles. And in that case, what we do as a data team is we ingest external data in the data lakehouse, we model it, transform it, and we automate the analysis. Another way of working is to have data scientists from the data team working in product teams. So it is for very specific data models, machine learning models. This is used, for example, for the green play, which is our self-consumption optimizer, or the smart battery or virtual battery analysis, or even the smart car charging station algorithms. This is basically one data scientist in the product team, and the value is there. And the last one is when you have a data analyst that is working in a sort of client-server relationship with the different services. So, for example, the supply chain will request a report, and we will find the data and do the report. And this is more of a client-server setup. One thing with this is you end up multitasking a lot. So it shows limitation when you are scaling up in terms of organization, this very centralized data analyst with a client-server type of organization. So these are the different examples that you can expect of how your data team is going to work with the rest of the enterprise. Plan, build, and migrate. So yeah, you have done your mapping, you have defined your target organization, both technical and organizational. So now it's about the build. So advice, start small, start with a pilot that you can identify in this process that you mapped earlier. In our case, it was the top area here. It was a process for energy billing. And do something that has an impact in terms of scalability improvement plus user pain points that you are going to address, and that is under control, like you have contributors available to work on it, plus it's wide but not too big, like you are not going to take 6 months to do it, but maybe 3 months, 2 months, a month, just to show the value of and prove your architecture. And then once you are done with this pilot, and if it's successful, of course, but you have only one option, you keep calm and you carry on. You basically tackle the rest of your data processes migration. For us, it was to migrate the low-code, no-code solution plus the green play from Azure Function to PySpark, and ingest the rest of the data from the ERP and CRM to offload the BI. And now the data lakehouse has all the data you need. Just to show you the technologies we are working with, the current stack. So Data Factory for the orchestration. Recently, we added DBT because we are investigating it. Why? Because it's very hard to maintain when your orchestration, when you have a lot of use cases to orchestrate and one is dependent on the other, it becomes complex, and DBT has the ability to handle the acyclic diagrams, which is good. We use Databricks, Delta Lake, which is basically storing Parquet files into a storage account. Could it be S3 on Amazon or blob storage on Azure. And we use Power BI to carry the data lake and provide reporting. And languages, it's PySpark, Python, and SQL. This is what it looks like for a portion of our architecture. So basically, you have a first layer where you ingest and transform, and you do it source by source. This is the most important thing here. Don't try to mix and match your sources at that stage, because you want the silver layer to reflect the sources and people to be able to find where is the data coming from. And then when you go to the gold layer, you have your analytics use cases, and you go with use case by use case, group of table, group by group of table. This is like your classical data marting when you do business intelligence. So what is important? Ingest source by source and do your gold layers use case by use case. Organize your code base. I don't think I should get too much into detail here. We have master notebooks, which are basically dealing with all the dependencies, libraries, installation, and so on. We have notebooks for the gold layers, and we name it all the same way, so we can refer to them easily. And same for the bronze and silver layer. We have those notebooks source by source. And we had already this discussion on your webinar many times, but it's basically notebooks to production, not or not to be. My experience is when you want to be agile and you want to go fast into deploying to production, don't think about being a data perfection where you put your code and you test it in a library and then you deploy your library and you put it into Kubernetes or whatever and you have everything containerized. That's the industrialization phase, FinOps, financial optimization as well. But when you are building it, don't focus on this. Just focus on making it work and making it collaborative. So I'm totally fine with notebooks in production. And actually, these days, when you think about it, the platforms are just so good at providing you the solutions to deploy testable notebooks to production that maybe we will laugh at us in the future on those things. Anyway, monitor the platform. This is something important anyway, containerized or not. We built a specific logger that can wrap the classic Python logger plus the telemetry client from Azure, and that can send both to the cluster logs plus to the platform. Then you can do dashboarding and you can monitor. You have a monitoring page for your activities, so you can check pipelines and activities that have failed and their error messages and drill down, whatever. This is a very good entry point in the morning to have your coffee. Cost monitoring, this is going to be an interesting slide because this was our cost monitoring during the migration. This is a full year of data stack cost at MyLight. What can we see? We can see that there is a baseline period where you just are observing everything, mapping everything. So not much price increase here. And then when you start to build the platform and you start to do your first pilot, your price will increase, of course, because you are running more compute and running and storing more data. And that's totally normal for the price to increase. You just need to monitor it in case you have a massive deviation compared to what were your expectations. And then as you will tackle the different stages of your migration, and you will do your deployment, QA, and then decommission, what happens is you will have an increase in price. And then because you need to have both the legacy architecture, for example, and your new architecture working together, you do your quality checks on the left side is same as the right side. And basically you have both running. So that's why you have the price increase here. And then you shut down the legacy architecture and price will go down. And same for the second stage. And if you noticed here, what you have is the new category of cost that is appearing in greenish here. And these are the analytics, because once you have deployed to production your data lakehouse, people are starting to consume your data. And this is an extra cost that you will have to your platform. So bear it in mind. This cost, however, it's going to be quite easy to manage because you start with an extra small cluster. And when it does not fit anymore the load, then you increase your cluster size. And usually this cluster is on from, let's say, 8 a.m. to 6 p.m., for example, normal working hours, 24 hours if you are distributed. But you can multiply, it's a cost that is easily calculable. Last step is to open the data lakehouse and foster collaboration. So for this, open data lakehouse. So one thing you need to bear in mind is to manage the access right to the data layers and the tables. So you don't have everybody accessing everything. Just make sure that you create groups and policies so people can only access to gold and maybe only to gold tables that are part of a specific data they were supposed to deal with, for example. But try to provide simplified access. In our case, we have both advanced users and not so advanced users. So we have the data workspace provided by Databricks, which is very good to do quick analysis, short-term dashboarding. But as soon as it gets industrialized, the dashboarding, the reporting, and we are happy with the exploration phase. Once it gets industrialized, we move to Power BI because it's easier to share in the company with the good access rights. And we use it for business-oriented reporting as well. So yeah, this is just an image to show you that we have both notebooks for data scientists to use the production data, the data workspace for data savvy users, and the Power BI for the industrialization phase. And wrap up and Q&A. So wrap up, it's basically a summary of everything we just discussed. Just to remind, so this is the screenshot we need to take, but of course I will share the slides. Map the current data organization and processes. So the most important thing here is focus on lineage, pain points, and bottlenecks. And you will use the mapping to identify a pilot. Then second step, define the target architecture. Remember that it's not only technical, but it's also organizational. So make sure to have the data people working together and working on the same in the same technical fashion. Minimize your data stack. Plan, build, and migrate. So start with a pilot and then you expand. And monitor the platform and the cost as you are building your data lakehouse. And finally, once you are done and that you have done your QA testing on portions of the data, and it's very important to do the QA before you open the data lake, because if people were used to carry the production database and your data is not the same or has been processed in a way that is not similar to what they are going to expect or they were used to carry, then you will have a lot of discussions that you want to avoid. And yeah, foster collaboration is to basically help the people to ramp up on becoming data savvy in a way. So that was it for the presentation. Alexei, maybe you want to go through possible questions?
Yeah, I do have a lot of questions. I'm not sure if they will be hard or not, but I'll try. So at the beginning, you mentioned that there was some magic software for ETLs, low code, no code. I imagine it's something like SSIS or like where you just drag and drop things, right? And connect. Was it SSIS or something similar?
Yeah, it was very similar to SSIS, probably based on the technology actually. It's called Magic Software, and the name I am not making it up.
So it's not like air codes. I see.
Software.
I see. So that's the actual name.
This is the actual name. Just Google it. Yeah.
That's funny. Okay. I thought it's like you did not want to refer to a particular product. That's why you kind of thought there's some magic software. That's interesting.
Magic Software for the joke. a lot of systems, and the credentials, there were like magic credentials, magic password, magic whatever, And when we decommission the thing, we are just like, what are those magic passwords everywhere?
Okay. Like, are there rainbows and unicorns everywhere in this software?
No. But it's
Okay.
basically, you open the software, you are back in the 80s with a low-code, no-code solution where you drag and drop, open, add window, add processing, add SQL query, and so on.
Like Informatica,
not many
like SSIS. Okay. Yeah. Okay. I'm just wondering, like, if you know why this software was used. Like, was it because it was easier to get started, or because people did not know anything else, or like there was probably a reason, right?
It was exactly this reason. It was somewhat comfortable to use to build the simple use cases that were present at the beginning of the company. But as you grow, you need to process more and more corner cases. And usually, I have a hate-love relationship with those low-code, no-code solutions, because they are very good to start. But once you reach a certain plateau, you can't really do everything with it, and you end up stuck. And that's basically where we were with this software.
Would you recommend for a new company to start with this no-code, low-code tool for the first ETL processes, or you would recommend investing time in something more, I don't know, maintainable in the future?
A good question. So if you have the people that have the technical background to be able to code, it's better to invest into a you-coded solution than a low-code, no-code solution from my perspective, because you still need to have the programmer mindset to use a low-code, no-code solution. And so it really depends of the people that are going to be there at the beginning of your company. If you don't have any technical profile, you can start with the low-code, no-code solution as a proof of concept, maybe. And as soon as it gets complicated, and you will notice it because you have no technical experience, you should probably ask consulting on what are you doing, is it correct? And see at that time if you need to code it yourself or to still do it with the low-code, no-code, I guess.
Okay, so the answer, it depends, and it depends on the technical expertise. If there is no strong technical expertise in-house, then it's okay to start with the software, but keep in mind that at some point you will need to actually hire somebody with the technical expertise to help you as it grows, right? And again, speaking of this magic software, how long did it actually take to rewrite these ETLs into PySpark and SQL later?
It took 6 months.
6 months.
But there were a lot. There were like 50 data flows, mostly dealing with the OLTP, so transaction between different tools and synchronization of data between ERP and CRM and things like that. But yeah, it took 6 months in total to migrate the 50 data flows. But bear in mind that we did the most critical ones first, and then we were a bit of slacky for the last ones because there were no that business critical.
So at first you decided you needed to think what would be the pilot, right? So then you went with the pilot, and then I guess I remember your recommendation was to time box it, not to spend more than 3 months on the pilot. So I guess for the pilot, you selected a couple of flows from this magic software, migrated them, and showed that they are the same, they are maybe cheaper, they are more maintainable, whatever, right? And then you migrated the rest.
Yeah, actually, the pilot was not concerned by the data processed by the magic software, luckily. It was already only analytical. So to summarize this energy billing use case, we were taking data from our IoT, the IoT we install at the client's places, and the data coming from the energy provider. from your meter readings, you know, and we were comparing them to make sure that we build in real time something that is correct. That was the use case. So it was, as you can see, already only analytics, because we had this database with the IoT data, and we have this other external data base with the metering readings. And both of them, it was only about ETL data in the data lakehouse and rebuilding the joins and all the analysis we do. So it was not concerned by the magic software, luckily. But to identify it, which was maybe your original question, the most important thing was to, when you are done with your mapping, to figure out the point in the more on the left side, on the right side of your mapping, that goes the fastest to the more sources, and the one which has the less dependencies. And this is the way you identify the correct pilot for your migration, if it makes sense.
And maybe the last one from me, because we also have a bunch of other questions.
Yep.
You mentioned that there is some sort of reference architecture. It's data Lakehouse Medallion Architecture or something like that. Where can we read more about this Medallion Architecture?
Yes, so the Medallion Architecture, it's basically Medallion is just for bronze, silver, and gold. That's what the Medallion is coming from. You can read about it on the Databricks website. It's very well explained there. If I can somehow summarize how it works, you have your raw data in your source, you append it constantly to your bronze layer, and then you merge the data into the silver layer, and then you join data and you aggregate it and you provide KPIs into the gold layer. So it's always about increasing the quality of the data layer per layer.
Mm-hmm. So it's kind of similar to. So from what I hear, it's kind of similar to this staging architecture from the old BI days. So the staging area would be like the bronze area, right? And then like after the data is processed, it kind of goes to the silver area, right? And then the whatever we built on top for the final dashboards is the gold layer.
Yeah, exactly. It's the Lambda architecture, where you used to have staging, data warehouse, data marts. Now you just have bronze, silver, gold.
Okay. Yeah, staging data marts, data warehouse, data marts. Okay. Yeah. Okay. Cool. Okay. I am going to share my screen because there's a question here. And the question is, what are different points to consider when making organizational target architecture?
What are different points to consider while making organizational target architecture? So first thing, I guess, is going to be the size of your team. If you have like one person in the data department, then you don't need to make organizational changes, I guess. But if your team is so if you have people that are working into services already and already building their Power BI reports, I think it's worth to ask them if they have the drive to learn about data, because they are going to be your best mates in this situation. So check if there are people in the company that have the ability to do reporting and to use the data, because they are going to be your consumers and they can become strong people in your organization, helping you do the job, basically. So start with this, and maybe they can you can identify them as a part-time data analyst, for example, and you can start having a sort of distributed data team where a few people that want to know about data, they are able, for example, to do Excel connection to the data lake, or maybe connect a Power BI and learn about Power BI. You can start thinking about this area. And when you are making organizational changes, you need to think, or let's say in the other case now, you have a big team. Sometimes bigger teams are harder to manage in a way that you need to split them. So maybe you want to split them into data science, data engineering, data analysis. That's the typical way of splitting the team. But I think regardless of if you have a centralized team, divided or not, depending on the size, or if you have people in the different business units, you need to have a sort of community where people do not reinvent the wheel in parallel. This is the most important thing, is to, whatever the organization you are going to put in place, make it so that people communicate. They have the same source of truth for the reporting, and they collaborate and share the work they do to avoid reinventing the wheel. I guess these are the important / different points to consider for organizational change.
Thank you. And there are also some questions in the live chat.
Yep.
So I am going just to read them. And the question is from Zafia: how much the landscape of the data engineering field have changed for the last 1-2 decades?
Wow, that's a big question.
Yeah, it is a very big question.
1 hour to reply to this question. How to reply to this? I will summarize my career basically. Back in 2013, I was doing ETL from IoT sensors to SQL databases. So it was mostly small data. The volume of data has increased a lot because storage has become cheap over the past decade, mostly. Cloud providers also have come into the game. So it has not been easier than today, I guess, to build a data platform, because you have all of those solutions and providers that are just making it easy for you to do this. First thing, yeah, so the evolution in terms of volume of data, this is what we call the so-called big data. And the technologies, everything is mostly cloud-based now. When you look at the advances into the platforms that you can use for developing tools, everything is online. Platform as a service, software as a service, online. You don't, I guess, you don't even have to install a database somehow these days. You don't need to, you can do Spark without installing your cluster yourself. Everything has been simplified. This is how the data engineering landscape has changed over the years. And streaming came also in the game, but from my experience, 90% of the companies are still in the batch mode.
Mm. Okay, so if I summarize, like 2 decades ago, or maybe slightly less, we had things like Oracle MS SQL service plus this no-code, low-code integration services. Then we had things like MapReduce on premises, and then you said we now have cloud, we have streaming, and it's never been easier to get started. All you need to do is just have a credit card, right? Go to Azure or AWS or Google Cloud Services.
Maybe you need a credit card and a data consultant just to make sure that you spend money properly.
But yeah, the first thing is important, because like how else are you going to pay the consultant, right?
Exactly.
Okay, so you need to have the money. But I guess previously, like, I don't remember how much Oracle costed, but it was a lot.
Yeah, the big shift, I think, and during the past 10 years was moving from on-prem to the cloud, and it's still the case for a lot of companies that have on-premise servers. And to be honest, this is still the case at MyLight. We have a part of operation that is still on-prem. And what I've known into the past years was to do the lift and shift. Like, you just take the on-prem architecture and you do a 1-for-1 in the cloud, or you do a rebuild / rework of the architecture. But most of the data projects you will work will include a hybrid between on-premise and cloud, and will require you to migrate at some point from the on-premise to the cloud. And I think this is the biggest changes the biggest change I think into the data engineering space.
But this is just a part of the question. So there is another interesting part is, how does the future of data engineering look like, in your opinion? So you mentioned streaming, right? That it's only 10% of companies use that, and the rest, I don't remember the number, but the majority still are the batch mode.
From my experience, I would think
more companies will go in the streaming mode, or
you think so? No, I think the future is about data democratization. It's going to be easier and easier when you see the advances in all of this current hype of the chat GPT and auto GPT and engineering GPT and whatever. You can imagine that you will have sort of semantic layers that will be managed by people, and you will have the queries of business people just in plain English, and they will somehow get their results. Some solutions are already doing part of it, I guess, on the market. But it's still a lot of work for a team to just label everything and to make it cataloged somehow. So I guess this is where we are going to spend the next years, into improving the quality of our data and the metadata associated to the data, so we can then use the advances in artificial intelligence to even do this cataloging and then carry the data. I dream of removing my job, to be honest, but so far it's proven that we still need data engineers.
You dream because you can do nothing and earn money, or why?
No. I think it's more of a metaphysical question, you know. It's about
because like, if you remove yourself, then how are you going to make money? Then you will need to change your qualification, right? Do something else.
Yeah,
like,
but
your skills become obsolete, and then AI just takes over your job.
But that's the perfection, you know. This is why we are building all of this, because in the end, I think the humans are creative people, you know, and somehow we are very how you say it, social creatures. And I think creativity and social creatures, if we automate all of the work, then we are good to go.
So we just socialize while the robots work, right?
Yeah. But anyway, I don't think I was the first one to touch on this question with this type of answers.
I think I watched Mandalorian some time ago, and there was an issue in one of the planets where robots went crazy.
Yeah.
People were so used to having robots do all the work, so they were like, okay, what do we do now? Because they just had fun, like they just enjoyed life while the robots were doing all the work.
Yeah, I think you get
yeah. There are still other questions, and we don't have a lot of time to talk about Star Wars, right? Another question from Zofia is, it's actually related to your talk, which is, my understanding is that Power BI is getting the data from the data lake. And is it not time consuming? Would it not be better to have a data mart between the data lake and Power BI?
Yeah, so good question. So your Power BI report is your consuming layer. It's the tool you are going to use to connect to the data lake and consume the data. When you do your Lambda / Medallion architecture, you remember you have your bronze, silver layer, and your data marts. And basically the role of this gold layer is to aggregate the data and make data sets smaller and smaller. So for example, you are going to already pre-compute the number of sales per month or whatever. And those data sets, which are reduced in size, they are then fetched by Power BI to do the reporting. This is the end result of the industrialization phase of your reporting. Of course, you have a dashboarding / experimentation phase of your reporting, which is you connect your Power BI straight to all the data, and sometimes it can be big tables. The performances when you are using Databricks to carry the data lake are quite good. I think the bottleneck with all the optimization they provide, like the photon optimizer and so on, I think the bottleneck is really your internet connection and the memory of your computer, to be honest, these days. So I wouldn't worry too much about the performances. And actually, if I can talk about this, the reporting before we migrated to the data lake was taking 19 hours per day. So a day is 24 hours, and 19 hours of it was spent refreshing reports. This was the situation a year ago. And now in 6 hours, you have way more data computing that we had in the past, plus the refreshing of the computer of the reports. And I think the refresh of the reports has been reduced by a tenfold, between 7 and 10 times faster, basically. I think the current reporting is like 45 minutes instead of probably 16 hours. And we have still 20% of the migration to complete. I can update on those numbers, but expect a minimum 5 times faster refresh rate for your reports. Does it reply to the question?
Hopefully, yes. I do not have enough background to actually say if it does reply or not. Hopefully, it makes sense for Zafia and the rest. What I want to say is it was a real pleasure to have you, Loïc, here. And I think I might have an idea what we can talk about on a podcast. Of course, if you're still open to invites, because your background, your career is amazing. And I think we can talk about that in an interview, but you will hear from us. So thanks for joining us today. And thanks everyone else for joining us today also. And watching this. And that's all we have time for today. And enjoy the rest of the week. And thanks again, Loïc.
Thanks for having me in this webinar. And thanks to your team that was in touch with me and preparing everything. And it was very nice to have this conversation with you. And I'll catch you soon.
Yeah, speak soon. Bye, everyone.
See you, Alexei.